Okay, now in terms of writing equations, right, make sure you always include water, and you need to recognize, is it a salt, is it a strong acid, strong base, weak acid? Okay. Now this is ethanoic acid, so if you put it in the water, make sure you include the equilibrium sign, and this will be the conjugate base on the other side, and there'll be plus H3O plus. Now I should put AQ on these, but not at the moment. Now this is H plus going over to H2O. Okay, so it's a proton donor, and now we've got the conjugate base, and we're writing an equation for that. And it's going to be the conjugate acid plus OH minus. Okay, and this time this is now accepting a proton. Okay, and here we are with a salt. Now this is really going to be split up into, now I should put H2O over the top of the arrow or have it as plus H2O. Do not leave it out. You do get marked down for that. Then on the other side, that's going to split up into the two ions. And then we recognise further that one of those ions is going to react in water and form CH3, COOH plus OH minus. So make sure you're happy with how to do that. If you have to write the conjugate acid base pairs, okay, for the first one that would be CH3COOH, and its conjugate base is CH3CO minus, and then we've got H3O plus. The acid normally comes first and the base comes second. Now these pairs differ by the one H plus. Okay, going this way you add H plus, and going that way you take away H plus. So you vary by one H plus only. Okay. Okay, and here we have NaOH as a strong base, and it just ionizes in water to form sodium ions, which do nothing, and it forms hydroxide ions, which of course are the base. This is nitric acid, a strong acid, and it's just going to form nitrate and H3O plus. Okay, so we just use the arrow here because these are strong bases which completely ionize, and strong acids completely dissociates, and so those ones are relatively straightforward. Okay, and just another example. Here we have the methyl ammonium, which is a first one, which is a weak acid, and because it's a weak acid we'll have the equilibrium sign there, and we just need to write the conjugate base. Okay, so this H plus gets given to the H2O, and that forms H3O plus. Okay, obviously you don't show these little things like this, is just to help you in your understanding. CH3 and H2, this is the amine, and again we've got the equilibrium sign, and that's going to make CH3NH3 plus, and will form some hydroxides ions. Now remember, most of what's present here is on the left hand side, the reactant. In both cases, forms very little in the way of the products on the other side. Now lastly, just to show an example of the salt, which is going to initially ionize in water and form CH3NH3 plus and Cl minus, use it the minus sign, and then we're thinking about the salt, will either of those react with water further? And of course CH3NH3 plus does, and we're just really writing that same equation from the top, and this is now in equilibrium, and this is why this solution, this is why this salt here would be acidic, okay, because it contains one of the components, one of the species is acidic, and it reacts with water to produce hydronium ions. Okay, so just one final point. If you're being asked to discuss some of these in terms of whether they're acidic or basic, you include the equation, you talk about the partial or complete dissociation depending on the case, but then it's important to make reference to what species are forming. For instance, why is this why is this salt acidic? Now you talk about how when it ionizes in water it forms these two species, the CH3 and H3 plus, the methyl ammonium ion and the chloride ion. And the CH3 and H3 plus ion, when it's in water, it's going to react with the water and it's going to form H3O plus. And the production of the H3O plus ions will create a pH of less than 7, making it acidic. It isn't complete, it's only partial, but you're linking that, you're linking the formation of the H3O plus ions to the concentration of the H3O plus ions, which wouldn't be that high, to the pH, okay, which is going to be acidic. It's going to be less than 7. And if you're talking about the amine here, you talk about how when it's in water it reacts to form the conjugate acid and the hydroxide ions, and how the hydroxide ions in solution are produced, and because they are produced, that creates a pH greater than 7. Okay, so it's important when you're talking about this to link the species to the pH, okay, and to use the terms partial and complete dissociation where necessary.